Shannon, are we all set? Great, excellent. Of course, my dog has also chosen to eat food loudly at this moment, so I apologize if you hear that in the background. Um, Good morning, good afternoon, everyone. My name is Reilly Loveland, and I am an associate director here at New Buildings Institute. And welcome to Unlock the Power of Building Control Systems, because hopefully at the end of this webinar, it'll be super clear how controls work, and our brains will be just fully unlocked. I anticipate that for sure, and I've seen some of the slides already. I get the great job of moderating today, so I get to just kind of vibe, listen, and learn, and ask both you all in the audience and panelists questions. Just a reminder, slides will go out. We'll send a follow-up with the recording. Feel free to put questions in the chat. I'll be monitoring that, and we'll pull it together for different folks. We also may answer some questions in the chat, but just know that I will also vocalize them. So welcome, listen, learn, also vibe. There we go. All right, so this webinar is brought in partnership with the San Diego Learn program. They provide free electrification webinars in partnership with New Buildings Institute, and you can head on over to San Diego Learn to find out more, sandiegolearn.com. All right, so we have this thing here at NBI, and if you have joined a webinar with me before, you may have seen our little friend. We use this polling software called Mentimeter, and whenever Mentimeter is around, we use our little Mentimeter marmot friend. So I'm gonna pull the system up, and then what all y'all need to do is take out your phones. You can also do this on your computer, so don't feel like you have to have your phone out today if you don't want to. If you do though, take your phone and scan your little QR code, and then tap into the system. So there's a little thumbs up down here. Yep, some people figured it out. So tap in, hit the thumbs up when you join. I'll give y'all just a couple of seconds to do that. And then note that as we move through this and you like accidentally close your browser or whatever, that little code shows up at the top again. So you'll be able to find it, I promise. And if not, I bet we can drop it in the chat. Oh, look at all the people joining. Thank you. It's so fun. All right, I'm going to move to the next question, but if you need a minute, totally feel free to take it. Oh, yeah, and if you'd like to, thank you folks for putting your names in the chat. If you want to say who you are, where you're from, maybe like your favorite color or your favorite season, I don't know, just tell us something about you. All right, on to the first question. Where are you calling in from today? We like this polling software because it has really nice little graphics. And it has nice colors. Yeah, and if you are not a polling software person, that's totally fine. We all have different learning abilities and learning styles. So feel free to put it in the chat. I see Jack did that. Thank you, Jack. I'm here in the Pacific Northwest. I'm in Portland, Oregon, and we're about to get some very Midwest weather today, Jack. So we're feeling you. We're going to get some nice little supercell storms. Nice. All right. I wonder if I can zoom in. No, I can't. But looks like quite a few people from the California area. I'm guessing this is Canada. This is cool. All people from all over. Kalamazoo, Michigan. Nice job. All right. Cool, cool. So I'm gonna just move back to the slides here, but this poll stays open. So if you need a few minutes to keep filling it out, it's really great if you do. But I'm gonna move back over to the slides really quickly because I want to talk about our webinar today. In today's webinar, we are going to discuss the many layers and complexities of building control systems, and truly many complexities. But this webinar does exist to help simplify some of those by providing optimization strategies for streamlining the performance, and then providing some best practices and real world examples from some folks in different sectors, but very similar, very similar pathways. All right, the marmot returns. Y'all, we do this like 4 or 5 times. So thank you for being a part of this. We love it, like I said. Oh, we have people from another country. That's cool. All right, what words come to mind when you think of building controls? I'm going to be real tickled by this one, so put in whatever you feel like. Make it work appropriate, though. In the chat. Impossible. Nice. All right. Automation. That's a big one. Energy consumptive, passive. Ooh, boring. Honestly, I feel that. Headache. Too many. Robot scheduling. Man, these are so good. Occupant comfort. I love that. I love the sort of like move towards the positive, but I fully understand that they are complicated and they take some time to understand. But golly, if you get them going, you're really good to go. Nice job, everybody. All right, so I'm actually just gonna keep moving because I could talk forever and this really isn't my webinar. So I want to introduce you all to our panelists today. This should really, so by the way, that will really help our panelists sort of like target their messaging today. It's fun to sort of target on the fly. But let me introduce all of our folks. So our first panelist, Mischa Egolf, a senior technical associate here at NBI on the Building Innovation and Leadership team and the Leadership and Market Development team, which is my team. We get her part-time, and she's wonderful. Mischa manages both the technical aspects of project work and with an emphasis on areas like data organization, tracking, data interpretation, and graphic display tools. She has excellent graphical skills. She works with stakeholders from multiple sectors to support building decarbonization efforts. And she works both with utilities, facility managers, and all walks of life. She can advise on both technical and policy issues. And I have to say, is just an A+ human, which she did not write in her bio, but I'm adding. We're also joined by Robert Nirenberg, who is co-PI, a principal of EduControls. He's been part of the building controls industry for 19 years, 5 years working as a contractor in new construction and service, and 6 years as the energy management system coordinator for a 1 million+ square foot community college. 6 years as a full-time HVAC and BAS faculty, and most recently founder and principal of EduControls. By the way, if I miss anything, panelists, feel free to let people know who you are. This is when I tend to not give as much credit to who you people are because it's just written on a piece of paper. Jason Majerus, senior engineering leader, principal at DLR Group. Jason has served as a lead mechanical engineer and project manager on an array of complex projects. He has a wealth of experience in system design for both new construction and renovation projects with a focus in energy efficient systems, sustainability, and central plant optimization and indoor air quality. All of the things important for controls. And then Scott Richardson, last but not least. I realize our pictures are a little in the different order, but we're going with it, keeping everyone on their toes. Scott Richardson is the MEP coordinator with Seattle Public School District with over 2 decades of expertise and experience in building automation. Scott has worked across many building types, including hospitals, data centers, school districts, high-rise building, residential projects. And Scott is currently serving as the Seattle Public Schools MEP representative for new construction, ensuring all the systems work together seamlessly. And this is the most interesting part, I think, besides the controls part. Before his career in building automation, Scott dedicated 6 years in the U.S. Navy, which provided a strong mechanical foundation for his professional journey. I will also say that Scott has a very funny, dry sense of humor, which I assume came from his many years in the field. So excited for y'all today. And I'm going to stop talking and pass this off to Robert. So I'm going to stop sharing and then Robert will pop his share up. Robert, okay, great.
All right. Hello, everyone. My name is Robert Nirenberg. I'm the principal of EduControls, as Reilly already introduced. So obviously today we're talking about controls, and I'm going to use some different terminology here. So we're going to talk about some definitions. So you noticed right at the beginning of my presentation that I said this was talking about modern buildings. Obviously, we're talking about commercial buildings because we're all here. But when I say modern, I'm talking about something designed somewhere after the 1960s from a mechanical and electrical standpoint. I'm not so concerned about the architectural standpoint as far as that's concerned. You know, remodels happen. We all know that. When we're talking about controls, of course, what are we talking about? Everything that's automatic with a building. Lots of different abbreviations are used, but predominantly we're talking about things like lighting controls, climate controls, or, just generically a control system. Design engineer, of course, is the person or team responsible for the initial design of a building's systems. Folks like Jason. So, yeah. Operating engineers, on the other hand, just to make sure that we're not talking about two different things, I'm talking about you. Building engineers, operators, stationary engineers. If you have something to do with the operations of a building, this is talking about you when I say operating engineers. Okay. So what's the purpose and intent of a control system? And that's, I'm really intentional with that word use, because we all understand the purpose, but intent dives a little bit deeper. On the base level, we want to make sure everybody is safe, healthy, and comfortable without using more energy than we need to. But we all know that that is an exceptionally simplified view. Safety is hugely complex. We're dealing with all kinds of codes. Fire systems, elevator systems are some of the heaviest with the codes. Healthy buildings, we've heard the stories from buildings that we built in the late 70s, early 80s during the energy crisis that were too tight of a building. We didn't have enough fresh air, so we got sick building syndrome. And of course, we've all been dealing with the impacts of health within our buildings for the last 5 years in a major way. Indoor air quality has had so many studies, and all of them keep pointing to more fresh air is better. Of course, more fresh air isn't always an easy thing to do for us, which brings us over to comfort and a little bit into energy as well. Buildings being comfortable, mostly we're talking about temperature, humidity, and light levels when we're talking about comfort. But there are many different things that could fall into that. And of course, all of these systems, all of these operations require us to use energy. And we want to be as efficient with our energy use as we can be. Because when we're being inefficient, we're being often ineffective as well. So we have to be really careful with that. So combination of those four things is really what the control system's goals are. So what do we control, again, in our modern building? HVAC, heating, ventilation, and air conditioning, lighting, refrigeration, fire protection systems, security systems, one of the newer aspects, perhaps. Shade controls in very new buildings, all kinds of things. Basically, we can control anything that we can write a sequence of operations for. Now, that may be a little bit simple to say, and as you know, hard to accomplish. But basically, any system in your building can be automated. Whether that makes sense or not, that's a different story. And that's something you are going to be able to understand about your building far better than I can generalize. Types of controls. So we're talking about controls generically, but as we all know, there are lots of different types of controls. And I'm not talking about the systems here, obviously, though I do have some system examples for each of the categories. And I'm also not talking about brands of controls. We definitely do not have enough time to talk about that in this, or at least I don't have enough time to talk about it in my part of the webinar. So most basic controls are your standalone controls. These are things that have one or maybe two different components to them. They control a single operation, and generally speaking, they do so very reliably. Things like line voltage thermostats, the automatic hand washing and flushing sensors in our restrooms, things along those lines. They're very stable. They've been around forever, and they're really useful in the right situation. Of course, it's hard to get any data from them, which is one of the things that drives our modern times is a lot of data. So next step up is our independent systems. So this is multiple components cooperating together, but they still don't communicate. So this is going to be things like a basic lighting control system, maybe dealing with occupancy of a series of rooms and having some switches that also interact with that. So again, been around for a while, pretty reliable, things like that. Integrated systems. Now we're getting into what most people are going to think about as control systems or building automation systems, my preferred nomenclature. And these are multiple integrated or independent systems tied together so that they can communicate back and forth. We are very used to this type of control system as part of our HVAC controls. Our climate control systems have been an integrated type of system for literally decades. So that is what we mean. When we can have the zone control talking back to our main plant, being able to communicate and know at the zone that our boiler is on or off, for example. Now, what I'm calling advanced systems, these are the new and coming. This is where we start to do a lot more integration between systems. So our lighting system talks to the security system, talks to the HVAC system. So when nobody's in the building, we know that because nobody's carded in, we can have the lights off down to a safety level, and we can have our HVAC in an unoccupied mode. Potentially very efficient, also very complex. Okay. Oftentimes we're also seeing an oversight type system of some kind, some sort of analytics system. I'm sure you've heard that term before. Companies like Clockworks or SkySpark are examples of that, where we are collating all of this data that our system is producing and having some sort of automatic rules that are combing through it to tell us when we have problems. Of course, more advanced systems come with challenges, right? You're familiar with these. We saw a lot of these in the word cloud, or the idea of them anyway. Complex. And of course, when we have more complexity, we also get more possible points of failure. The more devices you have, the greater the chances. We get complicated sequences of operation, particularly with our HVAC equipment, as we move from dealing with occupied and unoccupied mode to include things like occupied standby. Also, our more advanced dynamic reset schedules, whereas before, if it was 50 degrees outside, you got 60-degree air. Now we're actually looking at the loads within the zones to figure out what air temperatures we need. They're expensive to install, of course. I mean, well, what isn't expensive in a modern building these days? They're expensive to maintain. Our service contracts are expensive. Getting technicians out. When you can get a technician, they're, well, they're not cheap. It's a challenge for our operators to run these buildings this way. Everything has to be just so, or things start causing problems. And that's why you're here, is because you're trying to improve your ability to run these buildings. So why do we do it? Hey, this graphic looks mighty similar, doesn't it? Well, it's our same basic ideas. Because in reality, with the more advanced systems, we can make our buildings safer, healthier, more comfortable, and more energy efficient. Okay, so we're dealing with the efficacy of the systems. We make them more complicated so they can do their jobs more effectively. We also gain flexibility. That's one of the huge things with these more advanced systems is we can do things that we were never able to do before. The analytics packages that we can get can automatically point out common issues. We can flag when the music room goes out of temperature range. If it goes out more than 3 times in a day, we can have the system raise its hand and say, hey, there's a problem here. Okay. Code requirements are starting to require more advanced systems, particularly on the energy code side, but life safety as well. Building performance standards, for those of you who are in areas where those are being implemented, they're not codes, but they might as well be, right? Very similar application. And of course, the people who are using the buildings, who are owning the buildings, are starting to demand this, because if they're the owner, they don't want to pay more than they have to for utilities. And if they're the people in the buildings, they want to know that they're being responsible with their environment. Okay. So my last slide, some tips on optimizing your own control system. And these are super high level. These are things that you can do, though. Understand the basics of your system. If you've got a Johnson system, then you need to understand how it works. If you've got a Watt stopper system, that's your lighting controls, understand how it works at a basic level. You don't have to understand the programming code. You don't have to understand that. But you do have to understand how the inputs and outputs of the system work. Okay? Understand the intent of your system. Here's that word again that came back. When we first design a building, when the design engineer comes along, they work with the owners and the architects to come up with a system. And they have a plan for how the system is supposed to accomplish its goals. They work together, they figure out the goals. Then the engineers team figures out how they're going to achieve those goals within the code requirements. Okay? If you understand what that intention is, it will help you understand why your system is acting the way it is. And just because it doesn't make sense to you doesn't mean that's not how it was supposed to operate. Okay? You can ensure that the basic components of your systems are working properly. Your relays, your mechanical aspects, when they're supposed to be on or open, they are. When they're supposed to be off or closed, they are. You can check this. You know how to run overrides within your building. Go through and check things periodically. When you've got somebody who's out of the office and you know it, go into that space, calibrate the temperature sensors, check for your airflow sensors on the airflow side if you have an air hood. Make sure that your tools that you're using, however, are also within reasonable calibration. If you're using the $5 sensor that you got off of Amazon to calibrate your building control sensors, I'm not saying it's a bad sensor, but look at its calibration sheet and make sure that it's reliable. Okay. Also, make sure that your sequences are running in automatic control. Overrides are a very useful tool in the short term. In the long term, they are very parasitic for the function and efficiency of our systems. So if you have a VFD that is in hand, or if you have a damper overridden on your air handler, so that it's always open or closed, there was a problem there that was being fixed by that. But long term, it's going to cause the system to not operate optimally. Okay. Everybody knows you've got schedules in your building. This is another point where our overrides sometimes come into play. Hey, we've got a weekend event in the gymnasium. Could you make sure the lights are on? Sure. Quick exception or an override, and away we go. But again, we have to come back and make sure that those are cleared out. And the usage of our buildings changes. So make sure that your schedule matches the use of the building. Okay. And ask for help when you need it. Okay. You have managers within your facility that part of their goal is to make sure that you succeed. Get their help when you need it. When you need the help of a technician, when you're in over your head, HVAC, electrical, controls, whatever. There's nothing wrong with not being able to do something if you didn't learn it. Okay? Messing it up because you didn't learn it and knowing that you were in trouble and not calling for help, yeah, then maybe you're on questionable footing. And engineers. I know sometimes in the operations world, we don't necessarily always like design engineers, architects. They do make our life hard sometimes, but they can answer the complex questions that nobody else can. They can give you the real answer that is affected by code, not just a seat of the pants answer. So use those resources as you are able to, as you need them. My contact information if you need it. Reilly, do we have time for questions or save them for the end?
We're going to save them for the end. We're like a little bit behind, so I'm actually going to skip my next poll question, but y'all can probably see if you still have the Mentimeter app up that it is up. So feel free to answer it and we'll come around to the end. But I'm going to pass it off to Mischa here, who's going to talk a little bit about the overlap between controls and grid optimization. Go forth.
Thanks, Reilly, and thanks, Robert, for that great overview. So I'm going to go opposite of the direction of the question in the chat about simple, cheap controls. And I'm going to talk about the kind of more advanced integrated systems that Robert was introducing, specifically for creating a more grid interactive, efficient building. So as Reilly mentioned, my name is Mischa. I work at New Buildings Institute. I work on one of my projects is this Grid Optimal Buildings Initiative, where we do focus on strategies and technologies to help make buildings better grid citizens. And so I'm going to do a very brief spiel today. But if this is something that you're really passionate about, want to know more about, if this piques your interest, a lot of the information I'm sharing is a very condensed version of information you can find in this ASHRAE design and operation guide for grid interactive buildings. So that's available on the ASHRAE site. So if you're thinking about a grid integrated building, obviously efficient is one of the characteristics, but when we think about controls, what does that actually mean? How can controls help with that? And they can help the building be flexible, controllable, and connected. And so what that actually means functionally in terms of flexibility, that means that your building is able to shed or modify its load, either in response to a signal. So like the traditional thing that most folks are familiar with is a demand response signal. You can also do active load shaping, for example, preconditioning a space in anticipation of a demand response call, or turning the building on before you know that there's going to be occupancy, letting it float overnight, things like that. And then there's also, you can get really advanced with it in terms of providing ancillary services, depending on, where you're located and what's available. So those other two characteristics, controllable and connected, basically just means your building should be able to take a signal from the grid or some other third party like an aggregator and then do something with it. And then if you have two-way communication, it means that your building can kind of report back to the grid. So it could be one-way or two-way. In any case, if this is something that you're interested in pursuing, the communications should be standardized using preferably some sort of open communications protocol, nothing proprietary. So examples of that would be OpenADR or CTA 2045, which we typically see for water heaters. And yeah, as Robert mentioned, kind of like just different control systems in general, also thinking about communications, those can also be at the single device level. So just like a water heater at the whole building level, or even an aggregate approach. So you're aggregating a bunch of, let's say, a fleet of water heaters in a multifamily building. So there's a lot of different ways that you could do this, but these are kind of the principles to think about. So why would you do this? Especially as Robert mentioned, this can be very complicated. Things are kind of complicated at a baseline level, so why make it harder on yourself? Well, there are cost-saving opportunities. So the most traditional avenue, again, that most folks would use this for is like a demand response program where you could actually receive savings on your utility bill. There may be also programs for direct payments or other incentives and just generally reducing your peak demand charge for your building. So some questions to ask yourself if you're interested in thinking about this is, what is your building's peak load and how much money could you potentially save from reducing it? And also, where are you located? Are there tax credits, utility programs, or other incentives available for this kind of activity? And that's, there are other values as well. We know that cost is what things often boil down to, but you can also think about decarbonization. So thinking about those traditional demand response measures, but for carbon. So we know that, there's certain times that the utility grid is using quote unquote dirtier sources of energy. And so if one of your goals is to reduce the emissions of your building, perhaps for benchmarking requirements, like Robert mentioned, you can shift your building's usage to try to minimize the time that you're pulling energy that is from those quote unquote dirtier sources. Also, resiliency is another potential benefit of having these kind of integrated communicating systems, being able to manage emergencies, being able to island yourself from the grid if there's some sort of power outage. So that's something else to think about. And questions to ask related to these potential benefits is, what are the peak kind of high carbon hours for your local grid? And what renewables do you have on your system that are impacting that? And also, just generally, good to know what emergency mode looks like for your controls now, and if that's serving your needs now and in the future. So in terms of specific, specifications, I'm not going to go too in the weeds here. Again, that's something that's better suited for checking out that ASHRAE guide. But it's really about trying to kind of have this central brain. Ideally having remote operability so that you don't have to be, on-site plugging something in, and just making sure it's compatible all around with the utility communications and reporting protocol as well. So again, if you want to learn more, you can check out that ASHRAE guide. If you want to see buildings that have actually done this, we have a project roundup, some slides on our site, newbuildings.org/resource/grid-optimal. And we also have these fact sheets that talk about different technologies and different grid regions, different strategies you can do if you wanted to implement this. So with that, I'm very excited to pass it off to Jason, who is going to give us some actual real world examples of folks who have done some really great work with controls.
Thank you, Mischa. Let me figure out how to share my screen here for a second, but very exciting. Let's see. I'm gonna present here. Okay, so I'm going to do a case study real quick on the Cleveland Museum of Natural History, which included a controls upgrade. Definitely had some decarbonization goals on this project, which I'm really excited for the potential opportunity for grid integration and what that could do to an institution's decarbonization goals. That's definitely an opportunity there. This project started with the client's vision, and the museum was celebrating their 100th anniversary. And with this anniversary, they really kicked off this project. This project, they wanted to transform their facility, but also increase their community impact. And the project really wanted to follow their mission statement that focused on a sustainable future and a healthy planet. And the design team really took inspiration from one of the most basic and natural substances that forms our planet, which we all rely on, which is water. And you can see that water and glacial formations really influences the architectural design. You can see that kind of throughout this presentation. And that really serves to unify what was really multiple buildings built over several editions over many, many years. But this project not only focused on kind of a visual cohesion of these structures, but also all of the infrastructure, including the controls, was completely replaced under this project. And to just give you an idea of the complexity of this project, this is a research facility, a museum. It includes collection storage of priceless artifacts. And during construction, the building had to stay completely operational. The existing building was significantly modified. Some of the blue areas on the screen were opened to give natural light into the facility to improve the visitor experience. There was also a significant addition added to the building. You can see the number 4 there. That's the new wing. And there's a brand new collection storage area in the basement of the new wing. That's the area that has the strictest environmental control. And the basement's a perfect opportunity for that because there's really no interaction with the outdoors. There's no building envelope, no infiltration. So there's very few opportunity for outside influence of that space. So it's a way to really tightly control that space from a temperature and humidity standpoint. This is what the inside of the visitor hall looked like prior to renovation. Kind of a dark space, a lot of taxidermy in there. And then after the renovation, you see a lot of natural light, very clean space, and then again, kind of the glacial formations influencing the design. And now the visitors hall displays the museum's most prized artifacts, including Happy, which is the dinosaur you see here. That dinosaur was discovered by a team from the Cleveland Museum of Natural History back in the 50s. And that skeleton is about half of that skeleton is made up of real fossilized bone, which is rare for a specimen of that size. This is an image of the outside of the facility prior to renovation. That's the front door, surprisingly. And now today, this is just around the corner from that, but totally transformed. They were able to keep the existing planetarium, but just a much more welcoming space, transparent. These shots are at night, kind of showing the transparency that is gained. You can kind of see into the building, see what's going on. This particular shot shows the cafe with the overhang that works nicely during the day for the outdoor seating. The new wing has a brand new gallery and exhibit space. These exhibits incorporate new, but also some of the existing artifacts that they had, including this T-Rex, which is now viewable from the street as well. So you don't even have to, pay for admission to see some of the collections, which is part of the mission of the museum as well. So that's a little bit of an intro to the project. This aerial view kind of shows what it looks like, kind of stitching all of those existing parts of the building together. And you can see there's a PV array on the roof as well. But digging into the controls a little bit, the museum obviously needed a full upgrade. There were too many legacy systems in place for so many from many renovations over the years, and this project really had to start fresh with a new system. There wasn't really an opportunity just to slap a Niagara front end and bring in all those old systems. We really wanted to start with new. There was a new plant being installed and as a kind of a enabling phase, and the new front end was installed during that first phase, and then the subsequent phases, the control system was expanded. Phase 2 was what included the new wing. That was the largest phase of the project. It's the new wing, the visitors hall, which had Happy the dinosaur in it, and also the collection storage. Phase 2 included actually a satellite plant, and I'll tell you a little bit more about that in a minute. But the Phase 2 wing really had design goals that included sustainability, but also stable control for the environment within the museum for the collections. And the museum wanted to accomplish that using as few natural resources as possible. But for a museum, for collections, there's a lot of debate when it comes to, what the temperature and humidity control set points should be. And really my recommendation to, find out what those should be is to talk to the curator of the museum and the collections. But some institutions like the Smithsonian, they actually publish what those should be for their museums. And ASHRAE also has recommendations based on the type of materials that are stored. But stability is actually the thing that is generally not debated, and a stable environment for collections is actually the most important thing that you can do to really maintain the life of those collections. So there's two examples of control sequences that I wanted to touch on. Just to give you some examples of what we implemented into this project. So building pressure control with seasonal adjustment. So many of you, depending on the climate you're in, you may have sequences that pressurize your building and make sure that it remains pressurized, especially during the summer months. And in general, that is great. Having that pressurization helps mitigate infiltration. But for a highly humidified building like a museum, you have to be a little bit careful with that, especially in the winter months, because your indoor dew point could exceed the outdoor temperature, and that pressurization can drive moisture into the envelope. And depending on the makeup of the wall or the roof, you can be forcing moisture to the backside of the vapor barrier. So you got to be careful with that. And one way to mitigate that is to have a seasonal adjustment in your control sequence. So what we did in our control sequence is we're monitoring outdoor air temperature. We picked a conservative number that when the outdoor air temperature dropped below it, then we adjust our building pressure to a neutral or slightly positive set point. So just programming, for pressurization, we program an offset between outside air and relief air, but we make that dependent on that outside air temperature variable. Airside economizer. Economizer is usually a no-no in the museum setting, but as I said, like this museum had very lofty sustainability goals. So we explored airside economizer control plus monitoring. So looking at spaces that were less than critical and looking at implementing a sequence that, used economizer but monitored space temperature and humidity and the impact of economizer on that was how we implemented economizer. So how this would work is that, economizer functionality would be in place, but monitoring space, humidity, and temperature, if things got out of range for a period of time, economizer function would be disabled. That way, the system would have a chance to get back into range. So that's one way to do it in a museum setting. I wanted to make a quick point about humidity sensors. In a museum, humidity sensors are critical not only to a sequence like this, where you're looking at differential enthalpy control, you're looking at space humidity, but you really want reliable humidity sensors. And you got to make that investment up front on day one, but you also got to make that investment annually, or I would say periodically, based on the manufacturer's requirements for calibration, because they do go out of calibration. So that's something to talk to facilities team about at the start of a project, and talk about which sensors are right for the museum, because that can be a pretty large investment. So the plant for the new wing is a satellite plant that I mentioned. It uses a tempered water loop from the main central utility plant. And how we gain energy efficiency is through the use of heat recovery chillers. These chillers are geothermal ready, and this new wing could operate completely independently from the central plant if that geothermal loop was in place. And it also can operate independently in its heat recovery mode. So this is part of the decarbonization strategy that really aligns with that mission of, sustainability for the museum. Here's a screenshot. This is what the satellite looks like actually today. Took this screenshot this morning. You can see the tempered water loop in the greenish cyan color, chilled water loop coming off the chillers in blue, and the heating loop coming off the chillers in red. This morning it was 32 degrees in Cleveland, and the heating water loop was active. That was it. And then zooming in on the chillers themselves, the chillers have their own onboard controller. There's a BACnet interface with the control system. And this morning, only module 5 was active, and 1 compressor out of the 2 was operating in reverse cycle to create hot water. This is a typical air handling unit in the control system. These configurations are pretty consistent throughout. There are some single zone units, and then one of the air handling units has a side stream dehumidifier to actually dehumidify even lower in a dry storage space. And then real quick, just wanted to show you some trend data. This is collection storage, keeping at 68 degrees plus or minus 5%. This is the month of March. Using this trend data allows the maintenance team to really make sure things are operating the way they should. This shows humidity. You can see that it's trending 40% plus or minus 5%. But there was a little spike up to 51% before correcting back down. So it shows that, there's some anomalies that, you can go back and see what was going on. But this really helps the operations team figure things out. We're also helping the museum, as Robert mentioned, advanced systems. We're looking at a SkySpark overlay on top of this system that will pull a lot of these points and be a little bit more user-friendly interface to alert them of some of those anomalies. So where we ended up with this project, 32% reduction in energy use, central point of control for the whole facility, all that monitoring and trending, and a much easier to operate system. Final plug, this did achieve a LEED Platinum certification under version 4, first museum in the country to do that. So pretty proud of the team for accomplishing that. And with that, I am done. I'm going to hand it off to Scott.
Thank you, Jason. What an awesome museum.
Thank you.
We have 2 DLR projects going on right now, and they are beautiful schools. So DLR does a great job. Thank you. My name is Scott Richardson. I am the MEP coordinator for Seattle Public Schools, and I'm going to basically mirror some of Jason's slide progression, and then also go in a little bit of more depth from what Robert introduced us to. And thank you to the Buildings Institute for having me on this panel. So let's get started here. So we are a large district, the largest in Washington State. We have a ton of historical buildings that are hard to control because they're drafty. Now I got 106 buildings, 84 square miles of territory to cover, and 9.5 million square feet. Some of the challenges that we face with our building control systems are, number one, managing the amount of alarms that come through. There is some code, energy code, that requires you alarm a lot. And whenever those buildings come online, they're very noisy. There's component failures. There's thousands of field devices out there. And at any one time, We have hundreds of failures that we're chasing all the time. And then specific scheduling is a task. We could have one person be our scheduler, and that would be all they do. We have so many scheduling permit requests from individual organizations. And we have new legislation from the city of Seattle that we're dealing with to maintain EY targets for the Clean Buildings
Hey,
Act.
Scott,
And we
I'm sorry
also,
to interrupt,
yeah,
but I'm not
go.
sure we can see your slides. I'm
What?
realizing.
Okay. Just that second button. There you go. Is it in?
Yes, you're all good.
Thank you very much. Thank you for that. So I was going through these bullet points. Last point on this slide is we have multiple control vendors. So to go into a little bit more depth on the multiple control vendors, we got Siemens Insight, we got Siemens DeZigo, JCI, Allerton, and Delta, all actively used by our operators. And everyone has their preferences. We have a few experts from each on our staff. So we try to balance the challenge that way, but it's hard to keep up. Siemens Insight is nearing its end of life. So that was the only player in town for the longest time. They do have the majority of the schools. So part of our planning over the next 10 years is how to replace Siemens Insight with either DeZigo, JCI, Allerton, and Delta. The point here I'd also like to add is the BAS technology needs to move at the pace of IT. Server software is the reason why Siemens Insight is no longer supported. They don't live on the latest platforms for Microsoft. So that's why our IT said no more for these guys. Part of the implementation of building automation that we have to consider as a school district is when these new buildings come online, the systems have to be 100% commissioned before kids and teachers step onto site. So if you ever been on a construction site, schedules slip and the commissioning gets pushed down to 2 weeks and everybody's scrambling. So that's always a big challenge to make sure all these systems are operating at peak efficiency would be great, but just maintaining temperature control is what we usually settle for, then fine tune it as the year progresses. Sometimes we have to bring on swing shift, which of course is additional cost to the capital project budget. Some of the strategies that we've implemented in bringing these systems together is, do we want to build these systems via just a backnet communication network? Or should we land physical points on each of these smart pieces of equipment? To go into that a little bit further, suppliers do provide fully capable sequenced controllers, and they'll sell you, all you got to do is land a communication card or a communication network on this, and you're good to go. But what we found is the manufacturer's sequences don't always work that great. And if you're not familiar with the controls, if it's not the controls that you are using on your site as a whole, then you can't adjust your sequence, or you can't get a local company to help you adjust the sequence. So what we found is we don't want factory controls. Just give us the hardwired inputs to start the fan, adjust the fire rate or whatever you have. So that's true with VFDs, boilers, and other packaged units. So some of the tools that we'll use is a portable operating terminal to program these field controllers to make them work, operate to the sequence that is required. And the programmable field controller is your best bet. You don't want your sequence to be managed by your front end. You want all of your fine-tuned sequences to be on the local level in the controller that's touching the pieces of the field hardware that's attached to that unit. If you have it on the front end, of course, any communication blip is going to make you dead in the water, like all those sci-fi movies when the mothership dies, all the drones die. So stakeholder involvement, I think, you know, your occupants, it's important to give those guys a level of control. I think Robert mentioned it. We had our tight buildings in the 70s. The operators, they want to be able to open their windows. They want to be able to adjust their set point a little bit. They want to have, you know, the ability to turn on their equipment when they're in their after hours. You try to squeeze all the energy out of these buildings and you end up making your occupants frustrated. So we try to give them, you know, something so they do have control to some degree. And at some point, we would like to give every teacher mobile access to their environment, either via their phone or their computer in their classrooms. Some of the sequences that we use to balance energy and comfort, of course, is scheduling. We schedule every zone. Every classroom has an individual schedule. We don't schedule a building. We don't schedule a floor. We schedule every classroom. Every classroom has an optimal start attached to it. So the zone can be up to operating temperature by the time the teacher and students arrive. And Robert touched on this too. I'll go into more detail. We allow the zone equipment to drive the central plant equipment. So we'll schedule the zones, but we don't schedule central boiler plant or air handlers. We allow the field devices to ask for their equipment that supplies them to turn on. So if we have open heating valves on a fin tube, we'll ask the boiler to run. The heating valve position will then drive the temperature set point. We put that position way up at like 99%. So if the heating valve is doing all it can, it still can't make set point, ask the heating system to increment their set point a little bit. Same with the VAV dampers, they'll turn on the AHU, and if the VAV dampers are wide open, we'll increase static pressure set point. So some sequences continued. We fine tune those set points. We have occupied, unoccupied, standby set points. It gets confusing for the operators because they're like, why the hell we got so many set points? But if you just break it out into those three conditions, you got your occupied heating and cooling, your unoccupied heating and cooling, and then of course we integrate the motion sensors from the lighting system. And if we don't see any activity in that room, we will relax the occupied set points by 3 degrees in this example. And then you can monitor CO2, and then you can adjust how much air you're pumping into that space based on the CO2 needs. CO2 is also could be used for occupancy in addition to like binary PIR occupancy sensors. So on this page, we got a graph of a couple applications. Here you see our cooling OC, heating OC set points, our standby set points, and then these are the actual set points. A lot of operators will look at it and I see all these set points. I don't know what the hell we're controlling to. So those are also displayed there. So that's a Johnson system here. Here we got an Allerton. This is a VAV. Again, all the set points, airflow damper position, and then our fin tube radiators are source of heat. So with that, our default mechanical system that we use here at the school district is a ground source water-to-water heat pump. We found that this is the easiest to maintain. It operates at the lowest energy usage. So here's our one of our newer sites that came online in 2023. We have 7 water heat pumps currently in this graphic. None are operating. And you got your 2 loops on the water to water. You got a condenser water side and a hydronic water side. The hydronic water side runs out to the building. You got 101 degrees going out and 80 degrees coming back. And so that's a pretty good delta there, 20 degrees. On the other side here, on the condenser water side, it pumps it right into the earth. So the earth either cools or heats our building via this ground loop. Here is an example of the ground loop manifold. And on the ground loop, on this particular site, we have the boilers on the ground loop. There's lots of discussion as to whether the boiler should be on the ground loop side or on the hydronic water side. If you guys got an opinion, you could drop it in the chat. So as far as air quality here, we use DOAS heat recovery systems. Here is a graphic of that, where we got outside air coming in. The outside air will pick up energy from the return air on the spinning heat wheel. And we will provide 100% outside air to these new schools for that increased air quality that they're finding. The more fresh air, the better. If the conditions between outside air and return air aren't right, the heat wheel will turn off and you can bypass around it. Here's our hydronic coil that is served by the water-to-water heat pump plant. So let's see, on this site, we got 51 degrees outside air and we got 70-degree return air. So picking up 51 degrees in, we're picking up 11 degrees, almost 12 degrees just from running this heat wheel in a circle. And for applications of museum and humidity control, these wheels also will transfer humidity. So if you're bringing in cold, dry air, you can pick up all that humidity you pump into your museum also with these heat wheels. But we don't worry about humidity too much. So here is an example of one of those DOAS units. I think we're right here. This is where we have the heat wheel serving both plenums. And here we got outside air coming across the bottom, and then on the top we got return air coming across and exhaust air going up. Here's our VAV served from the DOAS unit, and we got a fin tube ventilation that along the windows, and that's what serves for our heating in the system. And this is our fresh air. You have to decouple your heating and your air systems now, so that's how we accomplish that. Displacement ventilation, I added this picture here. I'm not sure if you guys have ever seen that, but it's just one huge diffuser. It's got a very large footprint here. So you pump a lot of air at a slow velocity, and it just kind of trickles into the room. You don't even notice it. It's very quiet, and the teachers love it. So here you can see one VAV box coming into one diffuser. A big problem about this, though, being on the floor and being so quiet, is you might find a bookshelf in front of it. And here's the fin tubes along the window here. So using this system, we have quantifiably reduced our energy footprint. Only 18 of the schools so far are not meeting the EUI targets set forth in that Clean Buildings Performance Act. Here is an example. You guys mentioned Sky Spark. Here's an example of James Baldwin, Olympic Hills, and Viewlands on Sky Spark. Olympic Hills is individual heat pump per classroom. James Baldwin and Viewlands are the water heat pump systems. All three of these are ground source. But you see here Olympic Hills in green does have the peak. So this is where you start talking about peak demand energy. If your local utility says over 300 kilowatt hours, you're going to get a new increased rate. You want to look at this system and make sure whatever's happening here is mitigated. Here we have a weekend here. So all low usage. And then here on these little troughs, you have the nighttime operation. So Viewlands also has a lot going on at night, so that might be worth digging into. One of the differences for Viewlands is the ground loop condenser water also not only serves the water-to-water heat pumps, it serves IDF, MDF, electrical room heat pumps too. So those are running all night. So that could explain that. All right. A trend graph similar to what Jason showed here. So trends are important to manage your system. If you can, trend everything. The BAS vendors don't like to do that, but we try to push them as much as they can. So we have a nice history of how the equipment's been operating, because we got 106 schools. A lot of times we're not looking at this every day. We find a problem, we have to dig in. We need that history there when we need it. So my recommendation is to trend as much as possible and use COV trends, which stands for change of value. So when your input changes by a definable increment, you take a snapshot. That will give you the most resolution, and you're not wondering what happened in this 15-minute trend sample between 1 and 115. If it jumped and then leveled back out, you're going to see that jump with the COV trend. So future opportunities that we have in the district, we do have some of the advanced control. We are integrated to lighting over BACnet. We have hardwired connections to access control and the fire systems and the security systems, just to let the BAS in general know what the system states are. But future opportunities are to integrate with the increasing footprint of solar panels that we have on site. It would be nice if the factory's sequences were for the engineer's spec, and we could just plug and play, and we can just run a comm cable to everything. That would save a ton of time and money. We are seeing a lot of IP-based systems out there where the field controllers themselves are all IP-based. Those systems lend themselves best for the cloud computing that we're seeing. When the analytics are reaching down into your system's field level, you're going to need that throughput. We do have some advanced analytics on the Johnson system, but there is a lot in subscription-based, more definable. You can define the fault rules yourself, make your own rules, and that's on the horizon. Looking forward to seeing what that can do to help focus our priorities in our BAS maintenance. And we do have 3 systems we have to log into, or 4 systems, to see our entire district. It would be great if we had a solution that could overlay all of them and give us a single interface. But as soon as you do that, you're wondering where the problem is. Is it my interface gateway that's troubling, or is it something wrong with the field level? So you end up digging into the root layer anyway. So that about sums it up. BAS is a good system to have as long as you can manage all the complexities. And most importantly, they are fun to operate. So here's my last slide with, this is a Delta example. I showed Allerton, Siemens, Delta, and Johnson. And this is our example of a Delta. Thank you.
Thank you, Scott. And we fully recognize we have gone over time, but that is the nature of the complex energy controls world. There's an awful lot to talk about. We do have one more presenter that's going to talk about a training opportunity. And I think what we'll do so that people can go about their day, although I'm very impressed by how many people are still here. So thank you for your time. We will follow up any of the Q&A from the chat in a document that we share out too. So if you have that, please, I'm sorry, if you have questions, put them in the chat, anything you got. Also, if you have any like acronyms or shorthand, it's very helpful to type them out. So put them in the chat and we'll follow up with a document. And I'm going to pass it off to Jingjing and stop talking.
Thank you, Reilly. Yeah, I'm super pleased to see how many people are able and interested in staying. So if you have been enjoying all the informative contents that our organizer, MBI, has put together with all of our speakers, then here's one more learning opportunity for you. And it is very much focused on building automation systems, the topic we've been talking about today. So just a little bit background. Well, first of all, my name is Jingjing Liu. I'm a technology researcher at Lawrence Berkeley National Lab. I lead a lot of our grid interactive efficient buildings and demand flexibility efforts. And this training we're talking about is a second-year pilot funded by the Department of Energy Building Technology Office and in collaboration with the BEST Center, which is where Robert is from. The Department of Energy has been recognizing that there's increasing amount of technologies are being made available to the buildings, as you have seen with the previous speakers. And so that does create some demand and challenge for our current workforce to be able to learn new things and be able to keep up with all that. So that's why we're here to support that need. And we also, very much recognize that a lot of the facility management and operation maintenance crew are people who are kinesthetic learners. That means you master new skills by working with your hands and practice again instead of being just talked to, right? So in recognition of that, we have put together a very thoughtful training curriculum with the BEST Center. And we also make use of the Flex Lab, which is a very unique test bed here at LBNL site. But we take advantage of the building automation system interface and also some of the virtual advanced simulation platform technology to give you a risk-free, so you don't need to learn these by messing with your own buildings, but we give you that virtual environment to practice the same skills that you would be getting by practicing in real buildings. So this is our second-year pilot, and this is also in collaboration with the Department of Energy's Efficient and Healthy Schools program. So we do very much focus on and prioritize people who are working in the K-12 school facilities. So just to reveal a little bit of the training contents we have planned, and this is very much aligned with Robert's earlier presentation. We cover a lot of grounds about the control basics, and we will show you how some of the common energy efficiency strategies work and how to implement that in your control system. These are very much the low-hanging strategies, relatively easy to implement. So we're going to focus a lot around that, and also troubleshooting. So, a lot of the schools are stretching very thin on resources, and being able to have the in-house staff to have the necessary skills to troubleshoot when problems come up is a very is a pretty big need around many parts of the country. So this is very much why we're providing this training for. And you have seen those trending capabilities in earlier presenters' slides. So we're going to get into that and also talk about how you program certain controls in your system, what's the implications are on your energy use, and which translate into energy cost. And again, for resource limited schools, that spending less on energy would also mean having more resource to spend on students' education and other critical needs. So here's just a little bit of feedback we have received from last year's training pilot. It was very positive. We had all of our cohorts fully signed up, and the people were saying this kind of hands-on troubleshooting training is really hard to find, and they feel very fortunate to be part of it and highly recommend for others. So with that, I'll just briefly mention that we have just made this year's pilot available online. You can see the link here. Hopefully it's short enough to take a note, or you can find it later in the recorded training session online. But we are offering 5 virtual sessions in consecutive weeks starting on April 25th. Excuse me. And these sessions will happen on Fridays, just recognizing that usually works better for facilities staff, and it will be a little bit more than half a day per session. We have a total about 25 seats available. And this is co-funded by the schools program at DOE. And as I mentioned, therefore, we definitely prioritize K-12 school facility staff to take advantage of this free training. So with that, here's my contact information in case you have questions about this. But thank you so much.
All righty, so much information today. Links to that training are in the chat. Like I said, we're gonna follow up with those Q&A answers and some of the core components of the chat in a document that we will also post with the recording and the slides. And I want to say thank you so much to our presenters. Feel free to come on camera, y'all, so we can see you and say thank you and bye-bye. You did great. There was so much information today, and I really appreciate everyone's time. And for those who stuck on, you really soldiered on there. So thank you so much. Shannon, Mischa, anything else?
Nope. Thank you, Reilly.
Thanks, folks.
Thank you, everyone.
Thank you. Bye.